Hello, everyone. I hope you can hear well. Welcome to today's lunch talk from the ANCHOR project, the Interreg ANCHOR project. My name is Elisabeth Kvarnström, and I'm replacing Maria Lennartsson today because she had to be somewhere else. Today we're going to focus on greywater, and I will start sharing my screen. And I can't talk and do things at the same time. I hope you can see my screen now. Yeah, okay. Excellent. Yes, our focus today is greywater. It's the fourth ANCHOR Lunch talk we're holding today. The ANCHOR project is an Interreg financed project where we're working on water-wise neighborhoods. And we're doing so by focusing on source separating wastewater systems where black water is collected separate from grey water and treated for reuse of resources, among other things. And we do this basically, the big thing with ANCHOR is that there are 5 demo sites in Sweden, Germany, the Netherlands, and in Belgium, from which we're drawing a lot of experiences and collecting it and putting it together as transition knowledge so that other cities can follow in the lead of these fantastic demo sites. We're trying to engage with stakeholders in many different ways, and this lunch talk is one way we're doing that. The partners in this project are mainly municipal partners together with research partners, and then we have Du Coop, which is an interesting cooperative that is running the system in Belgium. And today's agenda, we're going to hear from 3 of the, oh, 4 actually, no, 3 from the different demo sites. But first, before we're going into the greywater treatment at the demo sites, Dr. Gregor Rudolf Schopping from Hamburg Wasser will talk a little bit about why one should collect greywater separate from black water. What are the main advantages of that? After that, Ashley Hall, who is a PhD student at Lund University, working hard on the greywater treatment in Helsingborg, is going to give a quick overview of some results from 2 years of research there. Lucas Kortz works for Hamburg Wasser with the greywater treatment there. We will get a quick overview there as well. And before the questions and answers, we will also hear a bit from Ghent, from Dries and Jens, on the greywater treatment they have there and the industrial reuse that happens. Before I let Gregor start, I just want to make a little holler for our next lunch meeting, which will take place in 2025. Sounds crazy, but yeah, February 10th, and we're going to get a digital tour of Genfelder Au in Hamburg at that point. Okay, please, Gregor, go ahead.
Thank you very much for the introduction to the lunch talk today. I will share my screen and the slides. Now you should see my screen. So as Elisabeth said, my name is Gregor Rudolf Schopping. I'm working for Hamburg Wasser, and I will talk about why we should separate greywater from the normal wastewater. And I'm the project leader of this part of the ANCHOR project at Hamburg Wasser. To start with the big picture, I think you know it, but I want to stress it once again. We are facing extreme weathers, and climate change is bringing more droughts and floods and challenging our water management. And this leads to the urgent need for sustainability, and we need to adapt to sustainable practices and to manage our increasingly scarce water resources, but also the flooding that is coming. And that leads to the need that we need to rethink wastewater systems So we need novel and innovative thinking to adapt the traditional wastewater systems to the new challenges that we are facing. Before I start how we can do this, where is actually our wastewater coming from? And that's coming from the consumption of drinking water. And how is the drinking water use typically in a household? Here I have a figure of a average German household, and you can see that there's 5% of the drinking water used in the household is needed for room cleaning, over a quarter for toilet flushing. Then we use again 5% for irrigation, and then really the majority is for showering, bathing, and hand wash basins in the bathroom, 40%. And in the kitchen, we use around 12% for kitchen sinks and dishwashers. And then we have also a big share of 13% just for laundry. And if we want to categorize the greywater, the wastewater in certain categories, we can roughly say that the water for toilet flushing is black water, of course. And then if you consider room cleaning and emptying your bucket into the toilet, then this is also ending in black water. Irrigation is most likely evaporating, or depending on where you irrigate, maybe also going into the earth, in the soil. And then the rest of the water is gray water. So that could be water from the bathrooms, from the kitchen. And this is in Germany between 65 and 70% of all the drinking water that is consumed in a household. So let's say this is all gray water, and as I said before, we can consider water from the shower, from the bathtub, and from the hand wash basin as gray water, and this all three together forms a gray water that is called weak gray water. And what is typical for this? It means that this weak gray water contains soap, hair, small amount of dirt, and certain micropollutants. For example, painkiller cream that you're washing away when you're using a shower. So it is polluted, but it's weakly polluted, let's say. Then on the other hand, we have heavy gray water, and that is composed of the water from the washing machine, from the dishwasher, and from the kitchen sink. And from the washing machine, the water contains detergents, microplastics, fibers from the clothes, and also sometimes small amount of bleach. So this is a more polluted water already. And then we're going to the water from the kitchen, from the dishwasher, and from the kitchen sink. This contains really high contamination levels from food particles, from grease, from detergents, and what is really missing here is also some pathogens that you're washing away from fruits, or from the vegetables and the stuff that you're washing in your kitchen sink, and the meat, of course. So in contrast to this, why is gray water what is different to the black water? In black water, this consists essentially of urine and feces, and then a bit, of course, flushing water and cleansing materials such as toilet paper. And therefore it contains high load of organic matter, much higher than in the gray water. It contains a high load of nitrogen, mainly in the form of ammonia and urea from the urine, and phosphorus. It also contains a high load of pathogens, so bacteria, viruses, and parasites. So it's really not a nice wastewater, and a high load of various micropollutants that are all decomposed in the body from pharmaceuticals, and chemical elements such as heavy metals and trace elements. So you can maybe see that black water is really a different water than gray water, and gray water is easier to treat maybe. So why is there this importance for sustainable water management? We need to maximize our water conservation. So we need to recycle the wastewater not only to conserve water, but also to ease the burdens on the sewage treatment systems plants. Because if there's less wastewater coming to the sewage treatment plants, then yeah, they have a less higher burden. Then we have environmental benefits. So the separation of wastewater is helping to reduce the environmental impact, because we need less fresh water if we can reuse certain wastewater in the end. And again, we are decreasing the wastewater discharge. And then, of course, if there's less wastewater coming to the wastewater treatment plants, then we also need a different system sizing, or maybe we are not using the full capacity of our systems the entire time. So this ensures efficiency and reliability, and it prevents an overload and ensures the optimal performance of the wastewater treatment plants. And then, of course, there's maybe the factor of cost efficiency. So it can lead to cost savings in the water usage and wastewater management if we are separating greywater and treat it and reuse it. So then on the other hand, the benefits for greywater reuse is, we do water conservation and reuse, because we can reuse the greywater as service water, and by this we conserve the groundwater, and we can also manage peak discharges for in summer, for example, when we need a lot of water, because greywater is always available, constantly available, and that's especially nice when it's hot and you need a lot of drinking water or groundwater. We have an improved treatment. When we treat the greywater separately from black water, the process might become easier and might become more cost efficient. We have health and environmental benefits, because we reduce the risk of pathogen and micropollutants distribution, because we put less wastewater to the treatment plants, so we can concentrate more on the let's say environmentally harmful black water to treat it properly. And we can do even heat recovery from the greywater. So greywater is wastewater that is relatively warm compared to the other wastewaters, so we can recover heat from it. And it's especially nice if you treat the greywater before, because that means that your heat exchangers are not blocking. So this is also a good way to use it. Typical treatment methods for greywater are several available. We have neo-natural principles such as constructed wetlands. We have physical ones with the reverse osmosis, anaerobic ones with upflow anaerobic sludge blankets. And then we have several where we have biomass or the biology in different forms, in sessile form or in suspended form as a activated sludge process, or a membrane bioreactor, for example, or suspended and sessile as in a fixed bed bioreactor or a moving bed biofilm reactor. So you will, in the following minutes or hour today, learn about several of those processes. Potential reuse cases for treated greywater are many. And I think I've listed some here, and I think there are many more that you can think of, and always looking for new ways of reuse the greywater, treated greywater. The most common is maybe toilet flushing and irrigation, but then you can also do it for natural discharge and help, for example, rivers if they are low in water during the summer, so that they get better quality, or a pond, for example. Also, you can do heat recovery, as I said before, and you can maybe also use it for microclimate improvement in a district if you're using this water for open water areas or irrigation in this district. On the right side, there's a sign from San Diego where they use not greywater but recycled wastewater, and they use it for irrigation. So it is already happening. In the ANCHOR project, in the 4 demo sites selected here, there's again the process water for soap production In Helsingborg, the treated greywater will be used for swimming pool water. In Kerkrade, it will be used for clothes washing, and in Hamburg, it will be used for low water elevation in a local pond. And by this, I would like to stop my talk today and will forward the speaking to Ashley, who will present the Helsingborg case. Thank you very much.
Thank you, Gregor, so much. And yeah, now it will be Ashley's turn. And yes, there are some questions coming into the chat. We'll try and answer them after all the presentations. Thank you, Gregor.
Thank you.
And Ashley, the floor is yours.
Thank you. Let me start sharing here. Can everyone see it okay? Perfect. Yeah, so I'm Ashley. I'm a PhD student at Lund University and in Svea, Nordvästra Skånes Vatten och Avlopp. And I work at a facility called RACO Lab, which stands for Recovery Lab. So we are one of the demo sites and we treat wastewater from the new city district in Helsingborg, Sweden, called Oceanhamnen. It was an old industrial zone that has been redeveloped into a mixed use area. So there's residential, offices, hotels, restaurants, a daycare, lots of different use cases there. It's not a purely domestic use area. And the water from Oceanhamnen is divided up into 3 pipes that get sent to our treatment facility at RACO Lab. So we have food waste. There are food grinders in the kitchen sinks. In Sweden, we typically collect food waste in a paper bag, throw it out with all the other solid waste, and it gets turned into biogas. So instead of doing that in this district, we're piloting actually collecting the food waste in a pipe and sending it directly to a digester at RACO Lab. We also collect the black water through vacuum toilets, so it's quite a concentrated black water compared to a traditional toilet water. And then we also collect the gray water, which, as Gregor mentioned, is the wastewater produced from sinks, showers, baths, washing dishes, doing laundry. And so the gray water that we collect is considered a heavy gray water or high strength gray water. Once the 3 pipes arrive in RACO Lab, they're divided up into 3 separate streams: the gray water stream, which I'll go into more detail on, and then the black water and food waste, which both use an effluent anaerobic sludge blanket digester, followed by some more advanced nitrogen and phosphorus stripping. If we zero in on the gray water itself, I'm just now realizing that this is in Swedish, but I will translate it in my head. The gray water flows in, and then it goes into a collection tank, followed by an anaerobic biological selector, a larger aerobic basin, sedimentation, a drum filter, a nanofilter, and then heat recovery. So the collection tank is 80 cubic meters. The retention time in that anaerobic selector is only 30 minutes. And then we have about 6 hours in the aerobic basin, and we aerate that up to 4 milligrams per liter of dissolved oxygen. In the sedimentation, we have a surface loading rate of 5.2 meters cubed per meter squared. And we recirculate 90% of the settled sludge of the daily inflow, which right now sits around 85 cubic meters per day. We have a drum filter that's 10 micrometers in pore size, followed by a nanofilter that's 400 Daltons. And those act as a polishing stage with the focus on removing all of the micropollutants that remain in the water. So we mostly look at the pharmaceutical residuals that are removed by the nanofilters. And we also are in a trial period right now with ozonating the concentrate from the nanofilters to try to further break down those pharmaceuticals and then recirculate them to be further degraded by the bacteria. We try to operate the system at 2.5 grams per liter total solids with a settled sludge of 5 grams per liter. However, we have noticed that the gray water we have is quite different from a traditional wastewater. And what that means is that we have a limitation of the nitrogen and phosphorus compared to the organic matter coming in. And that has had a negative effect on our biological community. We have an overgrowth of filamentous bacteria, which has caused some issues with our settling. And so it's hard to get as high a concentration of bacteria And if you have less bacteria to clean the water may not get as cleaned as well. And we differ from the other two demo sites in that we do have a sedimentation separation step before our membranes. And so we are considered a pure activated sludge system as opposed to a membrane bioreactor. Like I said, we have some operational challenges. We have had issues with filamentous bacteria. We think that could be due to a nutrient limitation or a high content of VFAs, volatile fatty acids. Part of my research is looking into that. I don't have answers yet, but I hopefully will soon. And we also don't have a ton of knowledge on what operational parameters are ideal. We have now been in discussion kind of as our group to try to come and agree on some good settings. But being that we're the odd ones out with the activated sludge system as opposed to an MBR, we're trying to figure it out ourselves. And right now we're hoping that 2.5 grams per liter TSS is going to be a good fit for us. And then the final big challenge is the sedimentation. We have a lot of filamentous bacteria that causes bulking and poor settling. Then we can't concentrate our sludge to recirculate it. We also see that our drum filter after settling is actually acting as a further selector for the filamentous bacteria. And since we do recirculate our backwash from our membranes, we're looking into other options to try to see why that is happening and see if we can avoid the selection from the drum filter. If we look at the water quality that Raycolab achieves during the treatment process, you can see the influent after the sedimentation and then the nanofilter permeate here. We do see that the biology is still removing quite a bit of the nutrients, the COD, TN, and TP. However, when the sedimentation is bad, those numbers do tend to increase, and the nanofilters help to ensure that we get a good quality effluent water. So they do act more as a polishing step. Yes. If we put our effluent water quality, so that nanofilter permeate water, in the context of chemical regulations from the EU, if we look at the Urban Wastewater Treatment Directive, bathing water quality, the minimum requirements for water reuse, and then also the drinking water directive, we see that we actually fulfill most all requirements. The only one that we don't know for sure is the irrigation class A, and it's just because we don't directly measure BOD. But we could infer from our COD concentrations that we would be under the 20 or the 10 milligram per liter BOD limit. We just don't have the values to say that for sure. Then if we look at the selected pathogens that we do test for, we actually discovered via the pathogen values that we had leaking membranes. And so when we have the leaking membranes, we have regrowth in the effluent. And when we don't have the leaking membranes, we don't have any detectable bacteria in our effluent, which is how it should be. So we've finally fixed all our leaking membranes, and hopefully we'll get some more data just to ensure that we do fulfill all the requirements for bathing, irrigation, and drinking water quality. And we're hopefully going to expand our frequency of testing as well to really fulfill the Swedish requirements for drinking water quality as well. Gregor mentioned reuse cases. This is a rendering of what the bathhouse that we will give our water to will look like. And the idea is that we can actually use our effluent nanofilter water, which will be considered drinking water quality, to top up the pool in the swimming house, which will be nice. And then we also have the opportunity to replace all of the drinking water at the major wastewater treatment plant in Helsingborg. That's used as like cleaning or process water with the effluent water from Raycolab if we produce excess for the pool. So a quick summary from what we've learned in our first 2 years is that greywater can be treated to a high effluent quality with biological treatment and membrane separation. If we look at the chemical parameters, we see that biological treatment for greywater needs to be further optimized and studied to reduce issues with settling. We also know that there needs to be more research done to determine if we are compliant with pathogen regulations, specifically around reuse settings. But we see that the potential for reuse is high from a technical perspective. And I didn't go into this, but we've had some issues with getting the government to allow us to do our reuse. And so I think clear legislation is necessary on that for us to be able to do this in more sites. If you want to read in more detail about this, we also have a paper that was published last year, I guess the beginning of this year, in Water Practice and Technology. So you can get all these same numbers there, but will also have access to the PowerPoint. Yeah, these are my resources. And with that, I say thank you, and I'll leave it back to you.
Thank you so much, Ashley, for this great speedy overview of what you've been working on for 2 years. Thank you also for the reference, and I'm sure people will pick it up. I will, for sure. I think we'll save all the questions for later. There are some questions for specifically for you in the questions and answers. I think we go on to Lucas Quartz, who's going to talk more about the treatment of greywater in Hamburg.
Yeah. Hey everyone, I'm Lucas Kotz. I'm the operator of the greywater treatment plant in the Jenfelder Au. In Jenfeld, we have the Hamburg water cycle. That means that we separate black water, greywater, and rainwater. Today, I will concentrate my presentation on the greywater part. We collect the greywater in the houses. We have around 2,200 people there where we collect the water, and we collect the water from the washing machines, the showers, the sink, and also the dishwater. And we collect all the water inside the pumping station, and the water flows by gravity to the pumping station, the deepest point in the Jenfelder Au. And after the cleaning of the greywater and with the process, we use the surface water for toilet flushing and irrigation in our DBU project. And of course, in our Interreg project, we use the water for low water elevation. Now I will concentrate more about the process you see in this red frame, our greywater treatment plant in a container. So the water inflow comes from the greywater pumping station in our greywater storage tank. It has around 10 cubics of volume. And from this storage tank, we pump the water up in the container through our screw sieves, where we get the separated the solids out. Most solids are hairs and other small stuff that get in the gray water. Then it comes to the receiver tank. It's a small buffer tank. Get the water inside the system of our greywater treatment plant. Before we come to the fixed bed bioreactor, we have the disturbator pipe. It's for get the water level in every part of the plant at the same high. The water flows from the disturbator pipe to the fixed bed bioreactor. There we have around 6.75 cubic volume and around 400 square meters surface of the fixed bed. Later on, I will show you a picture of the fixed bed, and you can imagine how it looks like. The biology needs a lot of air. Therefore, we have a blower, get oxygen level around 2 milligrams per liter. The activated biology sludge comes from the fixed bed bioreactor in our ultrafiltration membrane. Here in this schemata, we only have one picture, but there are two membranes parallel. We have one membrane from Mitsubishi. It's with a pore size around 50 nanometers, and one membrane from Veolia seaweed with 40 nanometers. The clean water, the permeate, we buffer in a permeate tank, and after this we can use the permeate for reuse. in our Interreg project. Of course, we have to get out the excess sludge. We have excess sludge value and foam remover to get the foamed sludge on the surface away from the fixed bed bioreactor. Now some process data. We have sludge age of 13 days, sludge load with 0.05 kilogram BOD per kilogram DS per day, and total solids of 6 gram per liter. For the Interreg project, we analyze on 2 different sample points. We have the greywater inflow and the permeate water we analyze after the membranes. Now I will show you some pictures that you can better imagine how it looks like in the Jänfelder Au. The greywater storage tank with the 10 cubics. And of course, our pilot plant in the container. You can see outside of the pilot plant one of the membranes outside because there were not enough space in our container. And you can see the sieve. And the first door is on the right is our container control unit. And when you go inside the second door, there is a screw sieve and the receiver tank. You can see the greywater before cleaning here. Then we have on the left the blower, and on the right our process pump to get the water inside the membrane in the fixed bed bioreactor. This is our 6.75 cubics fixed bed bioreactor on the left, and you can see on the picture in the middle the fixed bed with around 500 square meters fixed bed, and in the middle on the bottom our homemade foam remover. It works actually very good. And on the right, you see how it looks when it normally works, with a lot of swimming sludge sometimes. And now we see our return sludge pump, and of course our membrane. Here in this picture, it's the membrane in a cleaned situation. And right there is a picture with the sludge inside of the membrane. The membrane bioreactor. And now you can see our newest membrane. We buy it for the Interreg project because we have not enough treated greywater with our old membrane, and now we can produce around 25 cubics treated water per day. And on the picture on the right, you can see the membranes very good with the hollow fiber. At the end, it's important to see how is the quality of the greywater, and the rules and the discharge permit. You see the rules of the DVA M277 and the permit of water discharge from our local authorities. Our analysis of the standard parameters and also the hygienic parameters, and you can say that our pilot plants meet all criteria, technical and qualitative, for usage for low water elevation, toilet flushing, and irrigation are unproblematic to use our service water. So I'm finished with my presentation. Thank you for listening. Yes, I'm looking forward for your questions. Thank you.
Thank you, Lucas. We'll have to do with my questions now. You talked
Okay.
you talked something about the solids removal that we can see on the picture here. I didn't quite understand what it is that you remove as solids.
The solid remover, you mean the sieve?
Yeah, the sieve. What do you catch in the sieve?
In this sieve, wait here, the sieve on the left picture, we could catch almost only hairs.
Oh, hair,
The
that's what you
greywater,
said.
yeah, there are a lot of hair inside, and sometimes maybe small plastic pieces
Okay.
from the sink, but the most solids we have are hairs.
Right.
From shower and sink and washing machine, you get a lot of hair inside the greywater.
Right. And then you also mentioned that there are two different membranes that you use of the same size but of different makes. Is one more efficient than the other, or what is the difference? I think you mentioned maybe the different pore size or something, but
yes,
that was the new one, right?
Yeah, this is the new one. We have the old one is a little bit smaller from the surface. It's around 50 square meters, and the new one, this membrane you see on the picture is 57 square meter. And the difference is also that the new one has 40 nanometers pore size, and the older one 50. But this is not really a big difference. We can see from the last month we try the new one. It's much more efficient. This is the seaweed 500S, and it's in Germany. It's the common membrane. You hear a lot about this membrane, and yet we also try to use it, and from now we have good experience. I don't know, maybe the older one is too old, and that's the reason why we have not the best produce of permeate. And this one is completely new. This can also be different, but from now we have good experience with this membrane.
Right, but the old one also meets the effluent from the old one also meets the reuse standards. Is that correct?
Yes, the standards are the same. We analyze both, and they are complete the same. In the hygienic parameters and also in the standard parameters we analyze.
Right, but that's fantastic. That's really good news that you can that whatever treated greywater you produce, you can actually reuse for 3 different purposes. To not discharge, but to, what do you call it, like refill for greenery purposes, to refill the pond. Is that the correct description?
Yes. In the Interreg project, to refill the pond in the summer months, to have a better microclimate at this area.
Right, and also in another project you're using it for irrigation and toilet flushing.
Yes, that's right.
Right, yeah. So you're really developing some really good experiences on greywater reuse in Hamburg-Wasser and Genfelderau.
Yeah, we try our best.
Yes, and it's fantastic. Thank you so much, Lucas.
Yeah, thank you.
We're going to look at Ghent and Dries and Jens, who comes from the Coop cooperative. We'll talk about reuse, greywater treatment or wastewater treatment and reuse there. Now we see you in the middle somewhere. Page now, if you go back to not sharing.
Yes.
Oh, yeah. Now, yeah,
Is
fine.
that good?
Yeah,
Okay.
yeah, that's good. Yeah, cool.
Just my camera, maybe. I'll try to.
Yeah, that would be nice. Yes.
Okay. Good.
Good.
I'm
Excellent.
sorry
Thanks.
for this little delay.
No problem.
So I'd like to talk a little bit about our greywater treatment facility in Ghent, where we aim to reuse our water that it can be reused at a local soap factory. So let's talk a little bit about the project we are working on here. Maybe you're already familiar with it from previous lunch talks. But what we are working on here is the Nieuwe Docker project in Ghent, which is a 400 housing units and a city building. And within this district, we are collecting separately the black water kitchen waste and the grey water, and we are treating it on site so that it can be reused by a local and nearby soap factory, which is about left in the corner. Today we are on halfway the project, so half of the district is built, and we hope to see the next inhabitants by 2026. We did some calculations at the start of the project, which is about 10 years ago now, and there we estimated that we could reuse about 30,000 cubic meter of tap water and make it suitable for process water at the local factory. So at this day, the factory is just using tap water to produce both soft water and RO for steam or other processes within the factory. For the water that we deliver them, in return, we receive waste heat, which they normally cool to the environment. So in this way, we have a little industrial symbiosis with the factory. So one important question that we asked ourselves before we were starting the project is, what is the water quality that we need to achieve to deliver it for the soap factory? Because it's the quality of the water is of course very important for them because they are producing the soaps. The water is directly going into it in their end product. So we need to ensure that the water quality that we give them is not a liability for their processes. So you can see here some parameters that we agreed with them in terms of what the water quality should look like. You can see that most of the parameters are very similar to normal standard tap water quality related parameters. And this makes it obviously from our perspective as a local on-site water treatment plant sometimes challenging to make sure that we always meet these requirements. If the soap factory is not able to receive our water for reuse, our second option is to refill rainwater pits on site when they're empty, obviously. So this year was a very rainy year, so we were not able to send so much water over there. And then the last option is surface water. So we're calling about the Nieuwe Docker, you saw the water. So the water always has to comply as well to the legislations of discharge on surface water, and you can see that they are less stringent than the ones from the soap factory. I think most importantly, the parameters that are that we have to be most careful about are the color of the water and pathogens that are present in the water to make sure that we deliver the right quality. So from this set of parameters, how did we approach then the design of the system, and what did we learn out of it? We'll come to that later. So we have our process layout is that first we have black water from the toilets and the kitchen waste, which is processed by our digester. Then the next step is a struvite reactor, which is recovering some nutrients. And then we have the pre-treated black water and kitchen waste, which we mix back with the grey water. So this is not two separate treatment lines. It's indeed first the pre-treatment of black water and kitchen waste, and then it comes together with the grey water. So our grey water treatment line is not treating only grey water. In the grey water treatment line, we have denitrification, nitrification to remove all the remaining nitrogen, phosphorus, and COD. And in the end, a membrane bioreactor with ultrafiltration, which gives us already a very nice, clean, and non-turbid effluent, but it still has a remainder of color, which we need to remove by, which shows here the technology activated carbon, before we extract the heat, which we bring to our district heating. And then in the end, importantly, we also add bleach for removing another amount of color of the water, but also to sanitize the water to make sure we don't have any pathogens present for the water that we send to the soap factory. So you can see we really chose a multiple barrier approach here to make sure that we achieve the desired effluent quality that the factory is needing. So in terms of numbers, you can see here some numbers. What is the potential of our installation in terms of water, heat, and struvite to be recovered? Last year we treated about 20 cubic meter water per day, but it will be in total about 60 cubic meter water per day by 2029, the current numbers. For heat, we are about having a potential of 200 megawatt hours of heat that can be recovered of the water, with a potential of 600 megawatt hours of heat that we can recover on the district heating. And for struvite, this is very minor. We only have now 0.2 tons of struvite that can be recovered, a maximum of 1.2 ton. So you can see, especially for grey water treatment, this is where the water recovered and heat recovered is where the main interest is, where you can create a local circular economy. What work will we still do within the ANCHOR project? We will aim to further increase our autonomy of our water treatment plant. We see that our operator, as for maintaining the water quality, has to be day-to-day present in our installations to make sure that everything is running and operational. And during the ANCHOR project, we want to, by doing some investments in automatization and control, and maybe changing some small layouts of assets, we want to make sure that we have a robust installation, which requires minimum presence of an operator on site. So we were looking into sensors for minimizing our aeration costs and usage of chemicals, because we are still using a carbon source for denitrification and iron trichloride for phosphate removal. We see the operation of the USB also very important, is that there we had issues previously with sludge washout, which were impacting the grey water treatment a lot. So that's also very important to take into account, that this whole cascade of technologies can also cause and impact the day-to-day operation of a grey water treatment plant. And in terms of water quality to the soap factory, we want to ensure that we always comply in any condition, and also take into account the operation and the way the MBR works. with the perfect effluent for the soap factory. So there we're looking into a sensors based on color to make sure that we always deliver the correct quality to the company. Last slide here is a sum up of what I see as the most important success factors for greywater reuse. If you're aiming for water reuse in between the neighborhood and industry, it's very important to understand very well the needs of the water quality. So this is an important work where you have to look what is the balance between the cost of implementing new barriers to make sure that you reach the desired quality and the impact that you in the end create by creating local water reuse. So therefore, it can, when the water quality parameters become too stringent or too high for a certain set of parameters, it can become very challenging to realize a feasible economic situation for an on-site water treatment plant. So I think there it's very, very important that you find together with the partner who wants to take up the water to have aligned agreements on the water quality and water uptake and how it is organized. A second message I want to give is to keep it simple. Every treatment step has a potential for failure maintenance. You can see that I talked about the risks of the treatment of black water impacting the well-functioning of the greywater treatment plant. So keeping the systems operational in an economic and feasible way is very important, and therefore it's very good to look within your project. How can I create impact? What is the most important? Recovering water, recovering heat. What quality should this water comply to, under what condition, and see what set of technologies are necessary to achieve that impact. Especially if you're going into water reuse for industry or bathing water or other aspects where color is an important parameter, I would advise to avoid black water treatment to be included in that, because it adds quite a lot of color to the water that you have to remove later on. And then the last message is try to optimize as much with automation where feasible. In the end, these on-site greywater treatment systems should have a higher autonomy. Otherwise, it's not feasible to have an operator being on-site all the time. So look in how you can automate operations to ensure lower costs, but never at the cost of the water quality, of course. So that is a challenge to make. So with this, I thank you, and if there are any questions, I'm happy to reply to them.
Thank you, Dries, very much. There are questions in the chat. Okay, shall we start with the questions and see if we can get Lucas on board? Now we only have Dries and Ashley with us. I think if we start with the first question. The first question was from Ernst van Beek. Can you use both light and heavy grey water for all reuse cases? Is a question. You can feel free to grab the question if you feel you want to answer.
I would say that it's less a question of the source of the water, but what quality it's treated to. So as long as you fulfill the requirements and you have enough barriers to protect from pathogen risk to public health, you could reuse any water to whatever reuse case you need. But I would say it's more the effluent quality than it is the influent quality that matters.
Right. Thank you.
I want to add with that,
yes.
if you also treat heavy grey water, you will also have much more organic matter in your influent fats. So this can also impact the treatment train or the functioning of your what you're designing. Sometimes, in some occasions, it's better only to focus on light gray water because there most of the water and heat is present, and then it can be that your treatment train in operation goes much more smoothly than under occasions when you also have to treat heavy gray water.
Mm. And then we have it from Lena Su. Question: why not mixed wastewater reuse? Then we don't need to separate. Is the question. Anyone?
I think this question is mainly a question about scale. It all depends where you need your local circularity or water or resource that is present in your wastewater. If we do mixed wastewater reuse, it can become much more challenging by treating the water to a certain quality with pathogens, with the other aspects. While separating them eases this job, and you can more look what is the most valuable resource at that local place. So, for example, if you treat only gray water locally, it's quite simple set of technologies. It can be operated with minor interference, and you can create quite a lot of impact with water reuse, either for toilet flushing or maybe irrigation. While if you also treat the black water on site, it will become a much more complex issue.
And I would like to add to that as well that I think Gregor was trash talking Blackwater a little bit too much to my liking, because it's a really nice product, and I come from the nutrient recovery background, and I think Blackwater is really interesting from a nutrient resource recovery perspective, and you can do that much easier if you separate them. So it's not only you not only separate these flows to improve the water reuse, but also to improve the nutrient reuse. So you get a lot of different aspects covered. Ashley, did you want to add?
Yeah, and I would say that I know in Helsingborg, a big driver as we're expanding the city is that if you do an economic comparison in our specific context, it is cheaper to separate and treat gray water on site and only send the black water portion to the main plant, because we just don't have the capacity in the pipes to treat all of the, or to move all of the gray water and black water together to the main treatment plant. So it became a capacity question. And building a separate treatment plant was a lot cheaper in our instance than digging up all of the old pipe and replacing it with newer, larger pipe to build in that capacity. So I think there's a lot of different drivers as to why you could end up in a source separated system, but I don't think that focusing on source separation rules out the possibility for mixed wastewater reuse. We still do need to have that, because we're not going to rip up all of our old sewer systems and add new source separated sewers. And I see this as something to be introduced in new areas when it fits the bill. It's not a one size fits all solution, but in our instances, this was the best solution that we had to offer.
I agree. Now let's see. We still don't have Lucas with us, so we continue with the questions. And then David Gustafsson is asking, why should the room cleansing water be treated with the black water, not with the grey water? And I was surprised too. I didn't think that. Dries, do they dump the bucket from swabbing the floors? Do they dump that into the? I wouldn't think they would, into the vacuum toilet.
I don't know. I don't know what people do in their apartments, to be honest. So some people might throw it in a special sink where they can throw in this type of washing water. Some people might throw it in the toilet. I think this is a certain habit people have, and they will organize themselves around it. I don't think it will impact the system as much.
I would imagine that you would want the people not to throw it in the toilet, at least not, once again, from a nutrient perspective. I don't want like the floor washing into my nutrients. So I don't know, Ashley, if you have an idea on. No.
I mean, for our washing water, we don't think that it's getting into our black water system, or that's not the goal of it. We've had some issues at the hotel with them cleaning the mops that they mop the floor with in the vacuum toilets, and then the mop head gets sucked up into the pipes,
Oops.
which isn't ideal. But other than that, we do not recommend that people put the washing water
Right.
in the vacuum system. It should
Yeah.
just be toilet paper, pee, poop. That's it.
Exactly. So I think, I mean, maybe when Gregor was talking, he's not here to explain. I mean, that's what people do if they don't have vacuum toilets, maybe. I mean, I throw it in my toilet because I don't have a vacuum system. And then it becomes part of the black water. But ideally, it shouldn't, I don't think. Another question from Ernst van Beek. Are there realized business case examples where the cost-saving benefits are set off against the investment of changing the sewage system, and what type of sewage system changes are recommended to realize a separate collection setup? I think you were touching on that, Ashley, that there are cases where it can make sense from a cost-saving perspective. It's just like different from case to case, right? Yeah. Shall we jump to the another question here? In Oceanhamnen, do you use any chemical dosing like flocculant or similar?
We currently use no chemical additions. As part of my research, we'll do a pretty limited trials of adding urea and phosphoric acid to try to equalize out the nitrogen, phosphorus, and carbon ratios. And we'll also test a flocculant. But we have some early results back from some microscope analysis of what type of bacteria that we have. And based on that, it should not, the filamentous bacteria we have should not actually be affected by using a flocculant to help with settling. We're hoping that's not the case. But we will test to add PAX as well, a polyaluminum chloride solution, to see if that has any effect. And also to see if that has an effect on the phosphorus concentration as well.
Right. Okay, we go down here with questions. What, from Lena Su again, what online monitoring tools do you use to ensure good treated water quality continuously? I think that's a Dries question.
Yeah, there's different tools that you can use to monitor your water quality. At this moment, we are looking into, we don't have, I have to say, the water treatment itself is normally automated with its own PLC control. It has different sensors to measure, for example, oxygen tanks and so on. But it doesn't measure on a minute basis effluent parameters as the ones that we have to comply to. We are within the ANCHOR project, we are researching into what sensors, like for example a color sensor or an ammonium and nitrate sensor, if it could be useful for us to automate our processes and guarantee always good effluent quality. This is something we are researching and expecting to do some experiments in the well functioning of these sensors on the water type that we have, to see what impact it can make for us.
Thank you. Another question here is, what do you do with the struvite?
At this moment, I think the struvite, if you can see the amount of struvite that we are producing, is an example, a pilot project. So we don't have any specific use for it at this moment.
How about in Recolab, Ashley? You also produce struvite.
Yes, we had a deal on a pilot basis with a company where we sent them the struvite and the ammonium sulfate crystals, and they created a little pellet. And I know that it was a bit before my time, so I don't have any of the specifics, but I know they did a test on agricultural land, and they saw that the quality of the fertilizer that was produced was roughly equal to that of a commercially produced fertilizer. That is no longer going on just because we haven't produced enough to make it economically viable as a product to sell, but we still do just kind of collect it, and the company whose system we use, they take it and they use it in their research process, but it is not a commercially available product.
Yes, I can also add that you also are you're looking into certification and like end of waste classification of your products as well. So there are processes ongoing to make it more into a product, and hopefully it's going to be some kind of product in the future with economic value. Another question here, what percentage of used water is recovered through the method in Ghent? 60 cubic meters per day as part of X cubic meters per day use of tap water? So the 60 cubic meters, I think, was your potential in 2029. How much is that of the actual use in 2029?
I don't have a crystal ball. We try to, in collaboration with the soap factory, try to manage to take up reuse as much as water as possible. This is a matter of two parameters. It's the one main parameter, and it's mainly the dynamic availability and uptake of the water. So we produce water at certain moments during the day, which will be, I think, when the district is completed continuously. But the soap factory is having certain operational schedules and buffering water for these operational schedules. And to align those two, it will be, it still needs to be decided if we need more buffer capacity at the soap factory or not to take up more of our water. This is something that we will evaluate with them. It's also taken up into the contract that they will engage themselves to maximally uptake our water, and that installing extra buffer tanks, if necessary for that, will be done by them. So this is something we will keep on monitoring in the future to maximize this reuse.
Thank you. It's an ongoing process and an ongoing negotiation. Henning Seltzer has a question here for Dries. From a perspective of now, would you still choose to mix up the black water effluent with the pure grey water?
That's a very challenging question. I wouldn't know where to go with that treated black water, so I think so, yes.
Yeah. Another question here, Vanessa Bolivar. Why are the reasons for not using grey water for toilet flushing? Is it economically better to provide it to an industry or a pool, swimming pool? Or do people do not want to use recycled grey water, or legislation does not allow it? Do you have plans in the future for grey water reuse for households?
I can hop in here. I think that grey water for toilet flushing is definitely something that people look at. It's probably one of the first things that I think about when I think of grey water reuse. At the scale that we're doing it at, where we are taking quite a large portion and then putting it into a semi-centralized plant, it's a lot easier to have one pipe out back to one user as opposed to having another pipe network to resend this water out just for toilet flushing. And so from a legislative perspective, from an economic perspective, from a building perspective, one pipe is a lot easier to get approved in our instance, and it's cheaper. It's literally across the street from the plant, so it's also quite short and easy to build in. And so I think that's why we went with that one. In terms of legislation, there's a bit of an ick factor from the people who make the decision about how do we know it's going to be safe. And there's I think a lack of like full-scale proof of concept, since we are kind of some of the first to be doing this. So there isn't very much precedent set yet to prove that what we're doing is effective, in Sweden at least.
Andres, do you want to jump in?
Yeah, I think there's a cultural difference between Sweden and Belgium in that sense. Maybe In Belgium, especially in Flanders, there is a culture of rainwater reuse. There's already a long-standing legislation that is obligated to install a rainwater pit when you build a new house. Lately, they even increased the size of that rainwater pit. So there's already the practice of having a secondary circuit, both in single houses as in multiple family houses. What we see in the projects that we are involved with or hear about when they try to implement greywater treatment on site is that they take the logic that especially if it goes to multiple family houses and apartments, that anyway for a couple of apartment levels they already chose to put a secondary circuit because they're obligated by law. Why not bring it just to all of the houses and then implement greywater treatment? The extra cost is minimal, and it gives the opportunity to do local greywater treatment and heat recovery, which can be beneficial. So we visited within the community of practice in Flanders a hotel where they evaluated this business case for them, and they saw still a feasible return on investment on this installation, just for reusing the shower like grey water to toilet flushing water.
There's going to be more greywater lunch talks in the coming years before we end, so we can get back to this question. Well, thank you for today. Thank you so much.